So we're going to do a little bit of handing off back and forth, so please appreciate your patience while we hand off. So just quickly to start, we are going to be sharing code at the end of this talk, which is all of the slides and the demo. You can clone it, you can run it locally, you can do it all later. So don't worry about taking photos of the code. Don't worry about that as we go through the talk. Just a quick highlight, what we're going to be doing is quickly motivating what we're doing. We'll do some code walkthrough, we'll do some diagramming, and then we'll do a demo where we see it all running live in the command line and in Logfire and Pydantic AI. So that's the plan. I'm Laura. I'm the lead design engineer at Pydantic, and this is Victorien Plot, who's my wonderful colleague. He's one of the major maintainers of Pydantic and Pydantic AI, so thank him for his excellent open source work. Honestly, like open source people not appreciated enough. Just quickly, if you're not familiar with what Pydantic has been up to, this is something we've heard quite a lot, is people are like, oh, I know Pydantic, the validation library, but what's this other stuff? So Pydantic validation, OG, it's data structuring and validation, and of course, type hints for your IDE and type checks at runtime, and everyone knows it and loves it. And then we have our new open source library, which is Pydantic AI, which is like a framework for orchestrating your AI agents, accessing things like MCP tools and resources, and it provides model agnostic support for all your providers. And then Pydantic Logfire, which is a classic observability tool plus AI observability. So you can think of it like, I mean, I probably shouldn't mention competitors, but if someone squished Datadog and LangTrace together, Datadog and LangFuse or LangChain together, that's kind of what we're doing. We're doing observability for your entire stack, your entire application, all your network calls, all of your API calls, plus seeing traces from your models come out. So we're doing the whole thing. And they all work nicely together. So Pydantic AI uses Pydantic for validation under the hood. So you can structure inputs and outputs from your models. So just a little bit about terms of art. I'm hoping this is not news to anyone, but if you're not familiar, when we say models, we mean these large language models, and there's a bunch of providers available. So, you know, the classical ones like OpenAI, Anthropic, and Google Gemini. Then we've got open source providers like DeepSeek, and we've got Fine-Tunes. Agents, we're just, like there's a lot of people saying the word agent, and they all kind of mean different things. When we say it, we're basically trying to describe the idea of a model which is set up to do something agentive on behalf of the user, usually with a third-party service, the outside world, some kind of API. So not just text talking to text, but pinging a service or accessing the world in some way. Tools are just basically, you can think of them as functions you can call, but they're just how agents interact with the world. There's a bunch of them being spun up in this MCP world, but there's also, you can spin your own up as you need to. MCP, of course, I've been saying this already, Model Context Protocol is this new protocol that was released fairly recently last year by Anthropic, and it is essentially a standardized way for models to access these tools, these function calls. And finally, A2A, which is an agent-to-agent protocol, and that's a way for agents to discover each other and talk to each other and, in fact, work out what is the right agent for the right task. This is, of course, very high level. I'm not attempting to do a deep dive. If you have questions about these, we're happy to chat after the talk. So let's talk about building stuff with LLMs. It's been our experience that you have this kind of inversion in your way of building. Like when you start just a classical software engineering project, you start off very small and it has like no features or, you know, one or two features, and your sort of feeling of excitement builds as you start adding stuff and you add tests and it starts to perform better. Whereas with working with LLMs, it's often very easy to just like throw together a proof of concept and something spits out and it's like, ooh, look, I've got a working project. And then you start to test whether it does what you want and you're like, oh, failing 10 times out of 11, wonderful. And then you start to see all these weird hallucinations and your sort of vibes go down the sad path. So I think that this is perhaps a little bit simplistic. I'll note that this is a graph that our friend Hugo Baun-Anderson designed, and I do think it's a useful way of thinking about some of the pain we're feeling when we're engineering with LLMs. But I will say this is perhaps a little simplistic. But yeah. Let's describe what is we're building today. about 2 weeks ago, we had a docs bash week at Pydantic. We were just looking at our docs going, oh, we've released a lot of stuff. We've been shipping really hard, and our docs have gotten a little bit behind the features we've been releasing. We really need to focus on this. So the team got together, and we basically spent a week just really smashing out docs, and it was very productive. But of course, after you do something like that, you start thinking of all the ways you could optimize the process. So we had some obvious failure modes when we were writing docs. One is that people were just using LLMs ad hoc, and they were putting in their own prompts, and they were like using whatever model that they were familiar with. And that's interesting because it produces really variant quality and really variant styles. And if you care about text consistency at all, this actually is kind of an annoying failure mode, because then the humans have to go through, review all of the outputs and try and like make them conform to the Pydantic voice. And of course, there's also things like differing levels of English, and some people are just more confident writers and some are less confident. So just a lot of like weird failure modes for writing for people, essentially. So we started asking ourselves, could we work smarter and not harder? And I want to say the caveat that we are absolutely not trying to get rid of humans at all, like human writers, human opinions, human stories. That's what makes any kind of docs or blog or vlog or anything interesting and textured and nuanced. So what I do not expect is an LLM to come up with an interesting, spicy opinion about using Pydantic types. Like, why would it? What does it have to go on? But what I do want to do is lower the barrier to entry for developers writing content. So hopefully, like, I want to like make our opinions clear that we don't actually think that LLMs should or could automate this fully, because what matters is the human instincts, the human opinions about the world that we can then hopefully format and share in a way that's useful that people respond to. So what we started with is this. This was on my whiteboard at home in Berlin, and sorry, it's a little bit hard to read. Apologies for my handwriting. But you can see it's a really half-baked diagram, and I basically knew that we wanted to have a bunch of resources that an agent could access. I thought maybe we want it to be an MCP server, but I wasn't sure. I knew that we wanted something where all of our developers could access it with whatever model and whatever IDE they were preferred. So I didn't really want to say you have to use this with Cursor, or you have to do this in the CLI, or you have to do this through some other interface. So we kind of wanted the LLM to be bring your own, BYO. And we wanted to be able to cherry pick specific examples for like pieces of writing that we liked, specific posts, specific social media. So we wanted to both have a kind of fixed set of system prompts that described what we thought was a good quality piece of writing, but then also enrich it with content that was specific to the thing it was writing. And of course, I initially had this big ambitious idea that we would output every kind of writing that we might do. So that would be emails, docs, blog posts, external docs and internal social posts. And of course, what we ended up doing was just focusing in on one of these output types. So we wanted to write a blog and then pull a PR if accepted by the human reviewer for like further discussion. But basically, like, this is just a way of saying that was a useful way to motivate our conversation and like get this whole project kicked off. But it was absolutely not the end point of how we sharpened our ideas about what the system was and what it would do. And I just want to kind of highlight that it's really helpful to, when you're exploring these complex, multifaceted, multi-armed systems, to start simple. And what we mean by that is like picking a specific use case, a clear problem or a pain point, and then expanding from there. So it's really helpful not to try to boil the ocean, but instead to zoom in on a specific thing where you have an opinion about if the quality is good or not when the model produces an output, and work on engineering just that one path, and then build your system up from there. I'll also wave at this post from Anthropic. You probably have all seen it by now. I think it's the whole piece is very good, but I think what matters for me in this particular quote is they're basically saying you don't always need an agent, and you should consider whether the agent is worth the trade-off of added latency and cost for better performance. And I think that's really important to keep in mind, and I highly recommend reading this post if you haven't already. And just to land that a little bit more, another diagram from my friend Hugo. Sorry, he's Aussie and I love him, and he has lots of amazing hot takes in the field, so check him out if you haven't already. And he has this wonderful diagram where it's basically just asking you, do you need an agent? And it's really like trying to land this idea of, do you need the system to control something, to touch the outside world, to touch a third-party API? And if the answer is no, maybe you should just use an LLM, and maybe you should just put some more engineering around what you put in its context, what goes into the system prompt. Okay, and now I'm going to hand over to Victorien, who's going to show you some cool code.
Thanks, Laura. So yeah, let's dive into some code. We're going to build our ghostwriter agent. It's an agent that we're going to give it some input. So let's say I want to write a blog post about Pydantic validation, and it will output things markdown for us. So the first thing that you could do basically is just ask your favorite LLM client to write a blog post for me about some topic, and you will have a conversation about it. But the goal with Pydantic AI will be to express the same concepts as code in a structured way. So to do so, we're going to use the Pydantic AI framework, and here I'm using the word framework because there's a lot of similarities with existing web applications that you may have developed in the past. For example, if you're using FastAPI as a web framework, Pydantic is actually used under the hood to perform the validation of the type hints that you provide. So here, if ID is like a pass parameter, Pydantic is used to enforce this type. So it's like really an ID, an int, sorry. And similarly, if you're using a database backend, a database framework such as SQL Alchemy, you don't have to worry about which database backend is used, whether it's Postgres, MySQL, and such. You just have one unified API to query your data. And things are pretty similar with Pydantic AI. When we define an agent, we use this agent class, and every agent has a specific output type. In this case, it should give a number between 1 and 10. And we use the annotated pattern from Pydantic that you may know of. That is a way to add constraints to specific types. And Pydantic AI has the great benefit of being provider agnostic, so you can use either Google, Anthropic, OpenAI as any provider, and we have like a wide variety of support for models. If you want to switch from one model to another, it's just a one-line change in your application code. So let's use this for our ghostwriter implementation. We're going to start really simple by giving simple instructions. You are writing a blog post for the Pydantic blog. Because we wanted to output text, we're going to use string as an output type. And now we're going to see how we can give more context to this agent. Context in Pydantic AI is implemented using what we call dependencies. So you can declare like a simple data class where we're going to provide the blog author and some reference links. These dependencies are going to be provided for each one of your agent. You can also specify it in the agent for type checking purposes. Sorry. And yeah, when you and your agent, you're going to say, yeah, write me a blog post about some subject, and this is where you specify the dependencies. And to have the LLM make use of the dependencies, we use what we call dynamic instructions. Here you can see we're using a decorator pattern. It's actually something that is quite common in Pydantic AI. We're trying to reuse existing concepts in Python so that you don't get lost. And more generally, we really try to have the same feeling when you're using Pydantic with Pydantic AI, with like the same concepts, same APIs, the same type safety. So in this case, the instructions are going to use the dependencies to provide additional information, so also and links you may query. Laura is going to talk about how to provide more context with prompts, so I'm going to give it to her.
Thank you. Thanks, Ben. Yeah, so what do you want beyond your tools as context? Do you want system prompts, or you want to maybe compose a system prompt, which is what we determined. So we decided that we wanted to factor this nicely so that we could have some shared assets and we could have some agent-specific assets. And this is not terribly like groundbreaking or exciting, except to say that it's really useful to factor your system prompts in a way that's intuitive and easy to understand so that you can easily use or hide them and see if it actually adds any value. You can experiment with like a specific part of your system prompt and not have a monolithic piece of code with like a small annoying diff. So it's just a way of saying when you're doing evals, when you're doing prompt engineering, when you're doing experimentation, if you actually factor this nicely and you think about the system scaling, it will make your life so much easier. And just to show you a little bit of what we've been working on, like we have a global style guide, which can be called by both agents. We have also a vocabulary reference reference, which can be called by both agents. And then we have some things which are like agent specific. So here you can see the writer like instructions, and they're saying, you know, like, hey dude, why is this actually a blog post and not docs and not, you know, like not some other piece of output? So it's trying to force the agent to actually think about what makes this piece of writing useful. And also, by extension, humans, because we want to actually have some opinions about why this is useful. And of course, you have instructions for the reviewer, and the reviewer has just getting told like what we care about and double checking that it sort of matches the criteria for the output. I also considered, but didn't attempt yet, to send in another kind of system prompt, which would be a big book called The Elements of Style. I'm actually an English like humanities person from back in the day before I turned into a techie, and this is a really fun short book which establishes like the default of American high quality writing. And I was thinking this could be a fun experiment to see like if we throw this in the system prompt, does it actually improve the quality of the output or not? I don't know. Let's see. And I'm going to hand back to Victorien to talk about tools and tool calling.
Yeah, so now we have the ability to provide more context to our agent in what we actually want to write. But now let's say I want to write a blog post about Pydantic validators. The model has some training data with some cutoff dates, and it's going to be able to give it some reasonably well-structured blog post, but we want to actually give more information that the agent will be able to use. So we want to give more capabilities to our agent, and for this we use tools. Similarly to dynamic instructions, we use a decorator pattern for this, and a tool is basically a function that the LLM may or may not decide to call, and it's Python code, so it's really powerful because you can do pretty much anything you want. Like you can have a database query and run SQL queries on it to fetch, I don't know, customer data, if you're like writing a chatbot, for example. And in our case, I talked a bit about reference links that the agent may query to write the blog post. We can actually use an HTTP client and make the requests, and we use like the Trafilatua library, which can extract the content as HTML in a better formatted way for the LLM, basically. Again, here we have specific arguments that can be provided by the LLM, and we want Pydantic validation to be hooked up here. So if the LLM decides for some reason to give something that is not a link that will be queried, Pydantic will raise a validation error, and Pydantic AI will try to hand off to the LLM and say, hey, you made a mistake here. We want actually a URL that can be queried. Please try again. So a quick recap of what we have now. Our agent and some instructions and tools being with the decorated pattern. The nice thing here that we can see is that everything is declarative. Like you just define things with decorators, but actually under the hood, Pydantic AI is doing a lot of things for us. Whenever you do an agent run, it's going to create a graph and iterate over this graph. And each node can represent either a model response, a user request, a tool call, a tool response. And Pydantic AI handles all of this. And again, Pydantic validation is everywhere, so you don't have to worry about it. So we were able to validate the actual types of the data transmitted between the agent and the LLM. But we actually want to assess on the quality of the content. So there's a lot of things to do so related to evaluations. What we're going to do is introduce a new agent that we'll call the reviewer, that should give a review with a score and some feedback. Here the output type is a bit more involved. Instead of a simple string type, we're going to use Pydantic models. Again, you can use any constraint for the integer type. And this agent is going to take the blog post as an input, review it, and give a score back to the writer agent. To do so, we can just define a new tool for the writer agent that is just going to hand off to our reviewer agent. So things get a bit more complicated, so Laura is going to explain how, with diagrams, we can express these concepts.
This is actually just an example of a terrible diagram. I was trying to land the point that understanding your system and having a good mental model of what's going on is useful. So I just wanted to show you something I did with Claude that was terrible before I show you like actually what I found useful. I was describing like what I wanted to Claude, and then I showed it like the code base as we wrote it, and it gave me this, and it's useless. Like it's a bunch of color coding that makes no sense. Like this is not Pydantic AI. This is Pydantic AI. It was just completely wrong. And I tried it again, and it got worse. And I was like, okay, I have to start from scratch. And Victorien actually found this really useful D2 playground, which is a place that you can essentially write diagrams as code. So it's a nice little syntax. I highly recommend that you check it out if you're interested. And I started to like build the diagram up from here, and I found this much more useful. So we start with the idea of a user. They send a prompt into our agent. The agent can call the get guidelines tools, and it actually responds something, and then it can call the extract technical content, which then accesses the external world, a third-party API. And in fact, this is actually a little bit more complicated because you have resources. The resources are things that people, oh, can I pinch and zoom? Come on, buddy. Maybe in presentation mode I can't. Sorry, I was going to try and zoom in and out for you guys, but I'm feeling like that's not a possibility. Oh, what a shame. But yeah, we have resources, which are the things that the guidelines tool is doing. So that was those system prompt snippets that I showed you before. And then we can actually add our additional reviewer agent. Apologies, this has got a little bit complicated as it gets bigger. And then finally, we added another feature. It's hard to see, but you have to take my word for it that this is a tool called Create Blog PR, and that's pinging the GitHub API and pulling a PR for us. So this is, kind of getting to a useful agentive workflow. And I hope this is helpful to you, but basically the point I'm trying to land is it's incredibly helpful when you're not sure what you're building to actually have a system diagram that expresses to you what's going on, and it can be at whatever level of clarity or like nuance articulation you need. But yeah, I think that doing this is a really useful exercise, and your understanding and your shared understanding of what it is, that's the system, not the code. You guys need to understand in your brains what you're building, and that helps a lot. And now, Victorien is actually going to show it running in the command line in a Logfire.
Yeah, as Laura showed, like this system gets pretty complex, and it's really hard to understand what will happen when we do a model one. And this is where we introduce Logfire. So it's a commercial platform, as you will see. So to interact with our agent, we have a CLI, and I'll have to zoom in. If you can just talk into that. Oh yeah, thanks. So basically, we're going to run our agent through CLI. We have like an input file that is going to get the context, like the blog post name also and everything, so that we can run it as a simple command. So as you can see here, this is the context that is going to be given to our agent. The author role, some opinions about it, and a reference link. So we're going to write a blog post about using Pydantic validators, and that's why I gave the link to the Pydantic documentation for validators. As a first try, I gave some user requirements to write no more than 2 paragraphs, and as you'll see, like the reviewer agent is going to be a bit nitpicky about our blog post. OK, so we just started our CLI to generate our blog post, and now I'm going to head over Logfire to actually see what's happening. I'm going to be zooming a bit inside if I can. So we have this primary component of our platform, which is the live view, where you can see things going on for our agent run. The nice thing here to see is that even ongoing traces are being displayed, and you can see the responses from the tool of the agent as it goes. So it's really useful even during development if you need to try out things with your agents. You don't have to wait for it to finish to actually get information. Logfire is general purpose observability, but we have first-class support for AI applications, which means that for any agent run, we get some nice UI for it. So for our first writer agent run, we get information about the model name. One important thing is the tokens being used and the estimated cost for it. As you see, it can get pretty costly. As you can see from previous one, we have like a lot of tokens being used. And we get the available tools for our agent. There's a bit more than one we saw in the code presentation. But yeah, we have like the main ones: extract technical content, create blog pull requests that Laura talked about. And then if I head into this part, we can see the different prompts for. Yes, so wait about that. I'm going to make full screen. So we do have like the system prompt being given. You are writing a blog post for the Pydantic blog. We tell it about the tools that it can use, and we get the dependencies that are being injected as dynamic instructions. I'll try to zoom in a bit more into it. We then have the user request to write a blog post using Pydantic validators, and we can see the assistant response, which says, OK, I'm going to first use the get guidelines tools to fetch specific information on how to write the blog post. If I go over to this view, we can see the different tool calls that are happening. And in the end, we see that it's trying to call the review page content tool, which in turn calls the reviewer agent, agent and also those different tool calls. At the end of this one, we do get a response from the assistant. We should get, I think it's at this point, the review page content saying, OK, a score of 7 and some feedback about it. The writer agent thinks that 7 is not good enough for our blog post, and so it's going to retry again to do so. And that's why we see like it generated it and called our reviewer agent again. So one nice thing here is that you can see how many times your tools are being called, which can be important, especially if it goes into an endless loop. You actually want to avoid that in production. So it's trying to write it again and again, and it won't actually succeed to have a better score than 7. So we're going to run our agent again. And I'm going to show this after, this time with a different input. This one doesn't have any requirements in terms of like the length of the blog post.
Just to be clear, we told it had to be a certain length, and then Victorien's input told it to be too short. So we sort of forced it to fail so that you could see the failure mode.
And we do get a different trace for our next one. Hopefully it won't be too long, so we can see that it's going to call the reviewer agent only once, and this time it should succeed. At the end of this one, it's going to ask in this CLI if we want to publish a pull request for it. So hopefully we'll be able to see it if we have time. It's still going, yeah. But basically, in this CLI, it should output the blog post and have like a user prompt saying, do you want to publish it as a pull request on our repo? I can show you actually when it's running some demos that we did from other runs. We have like the Pydantic AI generated pull request with some description of the pull request saying, hey, this is an AI generated blog post and some content inside it. And we have like our blog post output. And we can see like it was using validators. We have like one paragraph, one code example. And if I head over to Logfire now, it might have finished. It's still generating. I think it got the review, so we can check actually how the review was when. Oh, it had a score of 8, which should be enough, I think. And now it's asking me if I want to create a pull request for this blog post. So let's try it. And it's still running, of course.
Check GitHub and see if it's up. Let's see if it's turned up.
It's still not up. Yeah, it's really hard to actually demo LLM stuff because plenty of, oh, it just finished. OK, great, the user has approved the pull request. So if I go to the pull request tab, I should get my pull request published. Yeah, we have it, finally. But it's really hard to actually, yeah.
I think we're almost at time, and I really wanted to have time for questions, but maybe we can squeeze in one?
Yeah, let's Please, maybe one question. So anyone? No, I think a demo is too impressive. Oh, okay.
Thank you for a wonderful and practical presentation. I think when using agents on everyone's minds is also the price. Is there a way in Pydantic AI to limit the number of executions or like the price, basically?
Actually, if I go over here to my Logfire code, we can see the final price for all these agent runs. And it's almost like, yeah, it's 10 cents basically, which is non-negligible or negligible depending on your use case. The nice thing here is that you can see a lot of tokens are being used. Maybe you can optimize things like your initial prompt so that it doesn't go over the reviewer agent over and over. Maybe you can reduce the number of tool calls which are going to use context tokens over and over as well. So this is what we wanted to show as well. Monitoring your cost, which is actually quite hard, especially that it's non-predictable. Tools may or may not be called, they may be called multiple times. So yeah, that's a nice way to actually do it.
Okay, yeah, I think we are out of time. Yeah. And let's give a pause for our speakers.
Sorry.